Welcome to your first video demo for Chapter 2, learning how to build frequency distributions. So we're going to be working with one of your homework questions, which stated, construct a frequency distribution beginning with a lower class limit of 400 and a class width of 500. It's the credit scores question. So the first thing we need to establish is a minimum and a maximum. Well, the minimum should already be established by the fact that we already have a lower class limit, but I want to verify that that is exactly true. So I'm going to say equals, I'm going to cheat, I'm going to use Excel, use the min function to establish the minimum from my range. So I just typed in the word min, hit an open parenthesis, and highlight the data, all the data set. So there's my 100 data pieces. Hit enter, and I should show that the minimum score is 444, and here I can hit equals max and hit the parenthesis set. So I'm just typing in min and max, which are reserved functions in Excel. You can also learn more about them on the insert function f of x feature there. So then highlighting again my data set, the first 100, hitting enter, and you'll notice that I have a minimum of 444 and a maximum of 850. The reason why the maximum is so important is I need to build enough classes. While they gave me the class width, they did not tell me how many classes I need to build. So beginning with a lower class limit of 400, I have a lower class limit of 400. The big thing here is the width. The width of the class is lower class limit to the next lower class limit. I must emphasize that. The class width of 50 is going to mean my next lower class limit is 450, making my upper class limit 449. If you were to count from 400 to 449, starting with 400, it is 50 iterations from 400 to 449. 400, 401, 402, 403, and so on and so forth would be 500 counts. That's very important. So this is going to then go to 499 because the next lower class limit here is going to be 500, and this is going to go 549, and so on and so forth. If you want to copy the series, you can just drag and hold the series, grab two of them, so highlighting, clicking and dragging, and then dragging again, I can drag the whole sequence. Now, I went way too far. Well, not way too far, because I noticed that my highest maximum value is 850. It has to fit into a slot, so I'm going to delete the last two because 850 is going to fall into this class. My lower class boundary, that's going to be 399.5. And the next lower class boundary is going to be 50 more than that, is it not? So I can make that be the next value, or I can simply say equals this value minus 0.5. So the trick there was to say equals the cell, and so on and so forth. Dragging this down, it can finish the piece. Upper class boundary is going to be 449.5. The reason why it's 449.5 is because that is the next boundary that is going to set one score from the other. So you could say this equals the score beside me plus 0.5, again giving me the 499.5. I can then drag and drop, and everything will change to be the case. On that drag feature, the key thing there is to grab the corner where the mouse changes to the little plus sign and drag it, and it will copy that sequence all the way down. So now I have my lower class limits and my upper class limits. I have my boundaries, and I want to point out right now that there are no overlapping pieces. So this goes from 400 to 449. This then goes from 450. There's no boundary piece that we don't know where they fall. The score of 850 is kind of a tough one. Where is it going to fall? It's going to fall in this boundary here, in this range here, if you will, because it's 850. And where does it fall? It's above this score, but below this one. So it's above 849.5, where that's the boundary. It's above the boundary, so it will fall into the next sequence. So now we want to let Excel do its trick, and to do that we must go to the add-ins and on the data tab. And when I go to the data tab, you'll notice there's a few things here, but it's also a couple things missing. To do this on the lab computers or from home the first time, you'll have to go to the Microsoft Office button, hit the Excel options, go to add-ins, give it a second to catch up with us, and then manage add-ins. You want to hit the Go feature. On the Go feature, you'll get a screen that looks like this. You want to add the analysis tool pack, hit OK, and I now have the analysis toolpack. Notice that my data ribbon now has changed to add the data analysis feature. On the data analysis button, I want to then do histogram. Now, histograms, the actual graphs of them, are tomorrow or the next lesson, but for now we use the histogram to use the computer-generated frequency distribution. Input range, your input range is always going to be your data set. So that's my 100 data members, my 100 credit scores that I'm analyzing. I can set them all up as such, where that's now my input data. So that's my input range is my data. My bin range. For my bin range, I'm going to use my upper class boundaries. So grab my upper class boundaries from my bin, and that's what you always want to use when you're using Excel to do this. The bin is the corresponding value is upper class boundaries. So make sure you use the upper class boundaries. Output range, I'm just going to stick it down here in the bottom of my graph. Oops, I blew it. On the input range, what just happened there is if you don't click on the box before you start selecting, it highlights the last thing you selected. So I had to go back and reselect the input, go back to the output range. Now I want to select my output range to come at the bottom of my graph, just so it sits there and I can work with the numbers. We'll just hit OK and see what happens. Okay, notice what happens. It says in the bin of 449.5 there's a frequency of 1, and the bin of 499.5 there's 1. And how Excel works is it says, okay, in the bin, this bin and lower, and this bin down to the next bin, this bin down to the next bin, and so on and so forth. So what I can do is I can copy my frequencies, and I hit copy, and I can paste it so I have my frequencies. Now notice I have here the credit rating. This is kind of cumbersome in a chart or an output, so what we might want to put here is I'll put a single quote so it lines up right, 400 to 449. I'll put a quote of 450 to 499. And unfortunately there's no easy way out on this. I'm going to have to suffer through typing them all in. There's no drag and drop feature on this one. And I'm going to make sure I do this right, because it'd be very easy right here to make an error to say 600 to 650. That would be an easy error to make. Remembering that 650 is my lower class limit, 699 is my upper class limit, making this one then go from 700 to 749. Oops. And you can see that the errors would be easy to make. And then going from 800 to 849, and then last but not least 850 to 899. So there we have it. Now the question does not ask you to calculate the cumulative frequencies, but I want to show you how it's done so you can be proficient in Excel here. Cumulative frequencies it's easy enough on the first one to just say, well, that cumulative so far is 1, and on my next cell what I want to do is say, well, that equals the new frequency plus what I've accumulated so far. So highlighting the appropriate cell, so I'm saying this equals what I just had plus what I've accumulated so far. And I could continue that same fashion down, or if I just drag the cell, I'm going to get all of that for free because it would then accumulate everything, so on and so forth. Cumulative frequency, kind of important at the end, we have accumulated all 100 scores, so we can see the accumulation of the scores. The other one is relative frequency. Sometimes that's kind of handy to look at. Where am I at relative to the others? So you could say this equals how many frequencies? 1 divided by how many? Well, there was a total of 100, was there not? So I can set up the 100. Well, that would be 1% or 0.01. Equals how many? 1 divided by the total number of scores. Now if I want to use Excel and do some shortcuts, I can say equals the number that just happened and hit divide by and hit this, and when I hit that feature I'm going to hit the F4 button so it puts dollar signs. You notice the dollar signs that appear here, making it stay put so that when I copy and drag it's still going to divide by that 100 and not drag itself down the chart. So I end up with these relative frequencies. If I want to make those look like percentages, I'm going to make them percentage format, so I can certainly do that with one quick click and make it work out. So you can see the percentages wise, and in this case the percentage relative frequency would have been easy enough. We had 100 scores, we had 27 of them, but in another example might be a little bit more cumbersome based on the fact that it might not always be out of 100 data members. So the last part of the question is asked us, does it appear to have a normal distribution? Well, your book talks about a normal distribution being it has a column that has the most, and going away from that, it slides downhill from each side. Now this does have a most column at 27. It does slide downhill to 19 and slide downhill to 10. The problem here is this is not symmetric, meaning that this is 19 on this side and this is 10. For it to be symmetric, it should be within 1 or 2 percentage points on each side. So this would have to be like 18. Notice that this one slides down slowly. This is like 19, 16, 12, 8, and so on and so forth. And this goes to 10 and then goes to 1 and then none. So it's not symmetric. So it has the first quality of being normal in the fact that it has a most frequently occurring one, but it is not symmetric. So it does not have the qualities of being a normal distribution. We'll see that a little bit more apparently when we do the graphs.